In this video, let us understand about partition and theorem of total probability. Now we are actually going a step ahead into the concept and trying to learn about the Bayes theorem. So as a first step or the foundation, we need to know about the partition and total theorem of probability. So consider a set of events E1, E2, E3, etc. till En, and let them represent a partition of the sample space if Ei intersection Ej is equal to phi for Ij varying from 1 to n. So, we have a sample space, yes, and we are dividing this sample space into n different segments, namely n different elements. So, we have each element representing the event. So, E1, E2, E3, etc. till En. So, what do we observe here? We observe that the intersection of any two of the events is a null set. And we also observe that E1, E2, E3, etc. till En are mutually exclusive. And each of their probabilities are greater than 0. That is, probability of Ei is greater than 0 for every I varying from 1 to n. Means that there is some element existing in each of the events and they are exhaustive. So, which means E1 union E2 etc. till union En is equal to the entire sample space. Thus, the events E1, E2, etc. till En represents the partition of the entire sample space S only if they are, first condition, pairwise disjoint, second condition, they are mutually exclusive, third condition, non-zero probability, and fourth condition, they are exhaustive. Hope you have understood, children. The partition of the sample space is done in this fashion. Okay, with this as the partition, now we shall introduce a event A which is going to overlap with these. So, if there is a specific event A within this sample space, what shall happen? Will it overlap with these events E1, E2, E3, etc. till En? Definitely yes. So, there is some overlapping portion which each of the events. The probability of this shaded region, probability of A intersection E1, that is equal to probability of A given E1 into probability of E1 by the multiplication theorem of probability. Now, if we have to proceed on the same lines for each of the events E2, E3, etc. till En, we will arrive at the total probability of P of A to be equal to P of E1 into probability of A given E1 plus P of E2 into probability of A given E2 plus etc. P of A given En into P of En. So, That is the total theorem of probability. Thus, we have probability of A to be written explicitly as probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus etc. Probability of En into probability of A given En. It can be simplified and written as probability of A is equal to sigma j varying from 1 to n of probability of Ej into probability of A given Ej. This is the general form of representing the theorem of total probability.